The purpose of this presentation is to address some questions that we have received after people have watched our some of our videos on EEPROM work, and there seems to be some confusion about what you can do via the diagnostic port on a car versus what you are able to do by working directly with the EEPROM part in the module. And one of the primary questions was, well, why would I need to do EEPROM work if I have a J2534 or JBOX interface and I can just do all of this over the diagnostic port? So I wanted to address that, and I also wanted to basically build a picture diagram for you of there are three options for working with the information that is contained in a module. And believe me, I'm all for diagnostic port work. It's the fastest, it's the easiest, it's the most simple, but it also, in some cases, doesn't provide you a path to a solution. So some things you can do with the scan tool, scanner. Some things you can't do with the scanner when you're working with a EEPROM in the module. And some things you can only do with the J2534 interface. So I'm going to do my best to explain how these different options work. And at that point, then I'm going to do an EEPROM swap, basically a clone. We're going to clone an ECU that I've got for this demonstration. So let me get started. Okay, once again, please pardon my my crude art, my inability to draw. Also, my whiteboard pen has a fat tip, makes it hard to write in the letters that you can read. So, did my best, and in this case, I'm gonna point out. If you can't read it, I'll read it to you. So, what I've drawn here is in the upper part we have the OBD interface, scan tool, JBOX, laptop, servers, and I'll explain how that works. And then over here we have a OBD port for the car. But this part is, this area here is what I want to spend a little bit of time on and describe how these pieces work in the module itself. Okay, so let me address that, and hopefully that'll build your educational understanding of what actually is happening in the module itself. So in this case, we have the in the module itself, it's going to have some kind of a microprocessor, microcontroller that is ultimately, that's responsible for managing all of the aspects of the module. In this case, we're going to reference an ECU. So, what are those pieces that are in the ECU that are required to basically make the ECU be the ECU? Its job is to manage all the functions of the engine, and as that is its task, it has to have a some kind of a central processing unit to perform that. And what does the central processing unit do? Well, the central processing unit, which I've labeled here as processor, it reads the instructions that compose the program that cause the ECU to be the ECU. Okay, meaning that it's going to go through a series of steps where it's going to basically control the fuel injectors. It's going to be looking at the air-fuel ratio with oxygen sensors. It's going to need to know the crankshaft position. It's also going to do things like manage, let's say you have a idler control motor, which is a stepper motor. It's going to be adjusting that. So all of those things are instructions that, believe me, the program in an ECU is not an insignificant program. It has to be, it's big, it has to be fast, because all of these things are happening in essence simultaneously, but the processor doesn't do things simultaneously. It does things one at a time. So the one at a time aspects mean it has to, in order to make everything look like it's happening simultaneously, it has to be whizzing around doing all of the tasks in its program to accomplish the functionality of the ECU. So when it's doing that, all right, where does the program reside? All right, the program is not in the processor. It's not here. It's in a separate memory part. Okay, and the separate memory part in most modern vehicles, no, not most, all modern vehicles, is what's called a flash memory part. All right, and flash memory is memory that can basically provide, it's where the instructions are stored, and the processor references the flash memory when it starts, and it says, okay, give me instruction number 1, give me instruction number 2, and then it executes that instruction, and when it's ready, it says, give me instruction number 3, number 4. And that's happening really, really fast. Okay, so this is what I'm showing here is like a bus between the processor and the flash memory. So it's reading all of those instructions. Problem with the flash memory is flash memory can read really, really quick. Okay, so the processor can be screaming along at whatever, tens of megahertz it's running at, and it's not gigahertz, it's megahertz. And it's accessing the flash memory, which is producing the instructions at a blazingly fast speed. But it's not, the processor does not write data back to the flash memory, because writing data to a flash memory takes a lot of time. And the processor does not have that time. Okay, so let's say that the processor is running along and it's reading all of the information that is coming from all the sensors and everything, and it needs to store those somewhere. Well, where does it store those? Okay, there's another kind of memory, which is here, called RAM. RAM stands for Random Access Memory. And a random access memory is if the processor is, reading information, then it's saving information that it's going to reference later. And by later, I mean while the vehicle's running. I don't mean later like the next day. Okay, once you turn the power off to the vehicle, once you shut it down, the data in the RAM is going to be gone. So, but while the processor is running it needs to store information based on calculations that it's doing in order to maintain the proper operation of the engine. The information that it's using to make those calculations not going to be here in the flash memory. It's going to be here in the RAM, and the RAM is also very fast. But the thing about the RAM is it reads really fast and it writes really fast. So you can move information in and out of the RAM at a high rate of speed. All right. So as the processor is running and it's reading its instructions from the flash memory and it's saving whatever intermittent data it needs in the RAM, everything's fine. It's controlling the injectors and it's doing all of the engine management functions that it needs to do. Okay, so that's basically the operation of how the system works. All right, how the module operates while the vehicle is running. Okay, so you'll notice over here we have the EEPROM. All right, and what I've done is I'm actually going to show you these parts on an actual ECU assembly so you can see them. The EEPROM has characteristics that are similar to RAM and similar to flash, but it suffers from the same limitations that both the flash memory has in terms of its speed. Okay, the EEPROM, which is a little teeny weeny memory part, and the one in the module I'm going to show you, it's 1,024 bytes, 1K. The EEPROM has to be read from and written to very slowly. So the processor, while it's doing the engine management work, it's unlikely to reference the EEPROM simply because it's very, very busy doing all of the other things that it needs to do. However, when the processor starts, all right, it's part of its initialization code, which is coming out of the flash memory, might be to check the VIN of the vehicle, okay, to make sure that the VIN in this module matches the VIN that's, for example, in the transmission controller, let's say, or some other module, okay. And if the VIN doesn't match, then the processor is going to probably trip a code. Or if you have some other issue, can't confirm or can't see the crankshaft position sensor, or it's getting invalidated from an oxygen sensor, or whatever, it will throw a DTC, a trouble code. Well, where is the DTC stored? Okay, well, it's probably going to be stored in the EEPROM. It may be stored in some other location on the vehicle, but in the event of for my explanation here, I'm going to say that the trouble code is going to be stored in the EEPROM. But what else is in the EEPROM? The VIN is stored in the EEPROM. There are other parameters that are specific to the vehicle, which are stored in the EEPROM. Okay, so the EEPROM, its function is to store small amounts of data that are specific to the vehicle. All right, so let's go over again what the parts do. Flash memory. It's got the program that allows the module to be the module. When it runs, the module's doing its job, managing the engine in this case. The RAM. The RAM is going to hold information that the processor, that the module needs while it's managing the engine. Okay, this could be timing information. What's another good example? Anyway, timing information, air-fuel ratio, whatever, stored in the RAM. Other things that it doesn't need when it's running its program to manage the engine are stored in the EEPROM. VIN, let's say it's got an immobilizing system. The key information can be stored in the EEPROM. It can be stored here in the ECU. It can also be stored in a separate immobilizer. But that's the function that the EEPROM performs. So we got small amounts of vehicle-specific data which are stored here, and we have the program code which is stored here. Okay, meaning the instructions that make the module be the module, and any intermittent data that the module needs while it's running are stored here in RAM. All right, so you might ask yourself, well, why don't we just store the VIN in the flash memory? Okay, the reason is that the flash memory doesn't allow programming of individual locations. Okay, it works with what are called sectors, which are large blocks of memory within the memory component itself. And in order to store the data in a block of memory, you have to erase the entire block of memory. Then you program back all of the bytes that you needed in that block of memory. Okay, so it's not only it's not conducive to storing like a VIN, because otherwise you'd be erasing a large chunk of the memory array and then programming it back only to update the VIN or only to update the key sequence. So what the engineers do is they'll use a little external memory part, the little EEPROM. And the information in these can be changed 1 byte at a time. So if you have a string, let's say the VIN, which is 17 digits, you want to, you've installed a new module, you want to update the VIN, you can program just the VIN. Now, some scanners let you do that. Some scanners will let you write the data to the VIN. Okay, so that covers what these pieces in this module do. All right, now the next thing I want to explain, and I want you to consider, is when a module is fabricated. Okay, meaning that the components are placed on the circuit assembly itself. And I'll tell you what, let me get a module and I'll just show you. Okay, this is a module I'm going to use later on in our demonstration. But let me just pull the cover off here. And here are all the components that are on the circuit assembly. And when they make this, okay, when they actually fabricate this with this assembly, all of these components are placed, and then it's placed where they're supposed to be, and then they're soldered, okay. And but maybe this is just as good a time as any to show you with this module. This is your processor right here. Sorry for the glare. Let me see if I can't zoom the camera and make this a little more clear. Okay, here is the when they fabricate this module, they place all these components and then they solder it. That's in and of itself is it's fascinating to see and watch. But let me just point out the pieces, the components that I had on the whiteboard. Okay, the big one in the middle here. This is a processor. All right. This is where the instructions are executed that make the module be the module. This part here is the flash memory part. And you'll see that it's got pins all the way around it. All right, that's because it's a parallel part, meaning the data has to, not serial like a serial EEPROM, it's parallel. So all of the data bits flow simultaneously. This part over here, this is your RAM chip. Okay, this is a 256,000 bits, which is 32K bytes. This part is 2 million bytes, 2 megabits. Okay, 16 million bytes. All right, so, and just some other things. This is an injector driver chip. I don't know what all of the other components are on here because I didn't spend any time analyzing it. But I wanted you to see it. Oh, and here, right here, this is your EEPROM. This is a 95080, and like I said, its job is to store small bits of vehicle-specific data. Okay, so now that you know, you can see what the parts actually look like that I've drawn on the whiteboard. Okay, so now we know what all the parts are. We're going to go in and look at how does the information get into the flash memory. Well, okay, the program, when a flash memory part is fabricated, it's blank. It's got nothing inside it. There's no program there. Just an empty array of bytes. So in order for the program to be placed into the flash memory, it's got to be, the flash memory part itself has to be programmed. Well, I will guarantee you that if you've done any J2534 work, programming is not a high-speed operation. Okay, so they don't do it over the diagnostic port when the car is manufactured. The parts are going to be pre-programmed before they get them, and they install them on the assembly. Okay, so the program that goes into the flash memory is going to be programmed while the flash memory part is outside of the assembly. Basically, they'll put it in a dedicated programmer, and they'll program the memory, and then when it's actually soldered to the assembly, the program is already there. Okay, so they do that because programming a flash memory part in parallel is it can be really, really fast, where if you had to do it over the diagnostic port, it would be really, really slow. All right, so basically the program is like flashed, if you want to use that term, into the memory, and then it can, as soon as it's soldered to the assembly, it's ready to go, ready to start. Okay, so that is what is done when the module is fabricated. But the question then arises: well, if the program is already there, how does the J2534 work? Okay, well, the answer to that question is there is another program aside from the program that makes the ECU be the ECU. And that program is going to also reside in the flash memory, but it's only going to run when the J2534 interface communicates to the module. And when that happens, the vehicle can't be running. Basically, the engine can't be running. Okay, so you will connect your J2534 interface to the diagnostic port, and it will establish communication over the diagnostic port. And what happens is all of the bytes that are currently in the flash memory that make the ECU be the ECU, they're going to be erased. Okay, and they're going to be replaced by new bytes, new code that come from the servers for whatever manufacturer's vehicle you're working on. Okay, so basically when you start communicating with the ECU, a separate program begins to run in that particular module. And what that program does is it begins to communicate over the diagnostic port, through the JBOX, through your laptop, over the internet, to the servers. But when you tell it to program, when you say, okay, I want to put the program, and the program is a big file on the server which flows over the internet, through your laptop, through the JBOX, gets converted into a series of commands which then go into the processor, and then the program that's running here says, okay, I'm not running the ECU now, I'm basically a reprogramming program. So what happens is this program that's running will erase part of the memory. This is a flash memory part, and as I said previously, the memory is organized into what are called sectors. So it basically goes in and erases all of the data that is currently in the part of the memory which makes the ECU be the ECU. And if you interrupt it at that point, or you do anything that will cause any kind of an exception to occur, you can brick your module, okay? Because it's running a separate program. You've got your ECU program, which is needed to make the ECU work, and then you've got your communication program, which is only used when you're reprogramming the ECU flash memory program that makes the ECU be the ECU. So I hope you understand that. So now, once you start communicating, this flash memory is being erased by basically a part of it holds a program which erases another part. It's kind of like a surgeon doing surgery on himself. So you do not want to interrupt this. And I know, if you watched videos of guys that are doing programming, they've got stabilizers they put on the battery because they say, we don't want the voltage to drop down below 14 or whatever the parameters are that the manufacturers say it shouldn't do. Because basically you're erasing the program, and that's what the communication program does. Then it erases the program in the flash memory. Then it pulls down all the bytes, okay, from the server through the JBOX over the diagnostic port, takes each individual byte, and it reprograms all of the locations in the flash memory that will allow the module to once again become the ECU controller. Okay, so that's how a J2534 works, and you do not want to interrupt that process. Okay. Now, at the same time, since the processor is running and a communication program is running, you also may have, if the manufacturer's lets you do it, you may be able to access the EEPROM and work with the data in the EEPROM. RAM is not in any way involved in this, okay, unless the RAM is part of it's being used for holding the bytes that come in over the diagnostic port to program into the flash memory. But so that's what's happening. The J2534 interface basically just passes a series of bytes over the diagnostic port, and a program in the ECU collects those bytes, erases the internal memory, programs the updated information, updated program into the flash memory, and then, at that point, you're done. All right. So I hope that explains it. That's what J2534 is. It's basically a direct interface which uses a communication program in the module itself to alter the primary program in the module itself and replace it with a new program that you're bringing down from servers on the internet through the J2534 box, and it erases erases and reprograms the memory in the module. Okay. Now, what does a scanner do? Because I know I've seen some videos where guys get confused. They buy a scanner and they think they're going to be able to do programming. Okay, well, trust me. Sometimes a JBOX, a J2534 interface will connect to a scanner, then the scanner connects to the diagnostic port. Well, it's basically, it's the same thing. But the scanner by itself, without the J2534, only lets you do whatever the scanner is programmed to let you do. Okay, so some scanners let you, if it's a bidirectional scanner, you can do all kinds of nifty things over the car's port or over the car's network. If it's not a bidirectional scanner, it'll just pull data out, and you can see things happening. Like if the processor's running and the engine's running, the scanner might be able to show you fuel trim, things like that. But some of the scanners will also let you do write to the EEPROM. Okay, and that's if you can get away with what you want to do by writing directly to the EEPROM from the scanner, then you can do your work. Okay, so that's pretty much it. I hope this helps you understand what happens between the J2534, a scanner. Okay, a scanner does not access the information on the servers. The scanner just talks, basically its program, whatever it's programmed to do, it'll do over the diagnostic port, read codes, write things, all of the things that whatever scanner you own does. It does not do this. It does not pull files or pull bytes from a server and stick them into the flash memory in the processor. All right, so its job as a scan tool is to allow you to read information, diagnose issues with the vehicle, and whatever other capability it has. It's going to give you the option, probably depending upon whose it is, to write certain pieces of information to the EEPROM, which is here. Okay. Let's move on to what is EEPROM Work and how does it relate. Okay, so what does EEPROM Work let you do? Well, if you want to replace the program that's in a module, do an update to the program that's in the ECU, this is not what EEPROM Work is about. Okay, EEPROM Work is about working with vehicle-specific information that's in one particular part which is in the module itself. Well, why is that a helpful thing to do? All right, well, take our module here, and let's say that this is, by the way, this module is out of a, what is it out of? It's out of a Cadillac CTS 2008, 2009. Let's say that this module doesn't work. You got a problem with the injector driver chip here, okay? It communicates fine, but this chip being bad, you wouldn't know that this chip was bad. You'd only know that it wasn't firing an injector. So what do you want to do? What are you going to do? Well, if you go to a salvage vehicle and take a module out of a salvage vehicle, what is going to prevent you from installing that module in the vehicle with which you're currently working? The only thing that's going to prevent you from installing it is the data that is specific to the vehicle that the module was removed, from which the module was removed. Okay, that information is in the EEPROM, which is right here. Okay, and that's what EEPROM Work lets you do. All right, you can take a defective module, and it just has to have one defective part. And let's, like I said, I'm assuming that, I'm just for my example, that the injector driver here is bad. But that makes that renders this module, it's dead. But the information in the little EEPROM is fine. It's just not right for the module from the salvage vehicle. So what do? Well, with EEPROM Work, you use a product such as our Automotive Kit. You attach to the EEPROM, you read it, and then you attach to your target module from the salvage vehicle, and you program it. And assuming that the salvage vehicle doesn't have any other defective components, all you have to do then is install it in the car, because the program in the flash memory is the same, and the processor is not going to know that the module is a different module, because the information that it's going to reference is here, and you've just moved the information from the module with which you are, from your vehicle with which you're working, into a salvage module. So that's what EEPROM Work lets you do, and I'm going to do it on this module just to show you how our product works. Okay, for those of you that have seen our other videos, I'm not going to spend a lot of time on the programmer, setting up the programmer, or any of that, but just so that if this is the first time you've seen the video or seen one of our videos, this is where we're going to basically just clone an ECU. Other videos, I did one where we did a VIN edit and other things that you can do with the Automotive Kit, but I'm not going to spend time doing that. So let me just zoom in here, and I'll show you quickly how everything is connected. Okay, this is the AR32A programming unit. With the Automotive Kit, you get our in-circuit adapter, which is here. You get the clip, which is here, and I've got it plugged in, I've got it powered on. I've already started our software. I'm not going to go through how that works, but I'll just switch over to the computer display. So you can see there's the software running. I've already selected the device, which I said before was a 95080, and if you look up here in the upper left hand corner, it says 95080, and when you select the part, it tells you how to set the switches on the programming unit. We've covered that in previous videos. So what we're going to do is we're going to attach the clip to what I am going to call the defective module, which is what I've labeled as module number 1. And that's here. You can see it says module number 1. Here is the double EEPROM. And I'm going to attach the clip, and then we'll proceed. Okay, to attach the clip, you squeeze it like that, and you open the jaws, and then the jaws go over the top of the part. Like that, and it grips the part. Okay. So now we will go back to the computer display, select command 5, which is the buffer editor, and in the buffer editor we have a get valid data command, which, as you've seen in the past, we press G for get valid data, and it will see if we're connected to the part. Alright, press G, reading the part, verifying the part, and there is the data from our defective module, read from the 95080. Again, our products are designed to do things in circuit. There's no unsoldering. We just attach the clip or read the part. Okay, so there's the data. It's in the buffer of our system. So the next thing we're going to do is we're going to move the clip over to our target module. All right, take the clip off of our source module, our quote-unquote defective module. Here is our target module. Module number 2, and we're going to attach the clip to this part, and I'm going to go back to the computer display. Okay, here we are back at the computer display. Now what I'm going to do, I've attached the clip to the part on our module number 2. This is our salvage vehicle module, our target module. Okay, but I don't know for a fact that the clip is actually attached properly, so we have a command in our buffer editor called Quick View. Okay, and Quick View will read the data from the EEPROM to which the system is attached, but it does not place it in the buffer. It just puts it on the screen. So I'm going to press Q, and you'll see that this is different data. This is the data from the salvage vehicle module. Now I haven't put it into the buffer. I don't want to put it into the buffer because I've got the data from our source module in the buffer. Okay, but the Quick View, if you don't have the clip attached to the part properly, or if the part has got some humidity sealant on it or something that's preventing it from getting a good read, you can use the Quick View command and determine whether or not you're connected, and if you're not connected, then you can take whatever actions you need to remedy the connection, make sure that it's proper. All right, so we're hooked up. Here's the data from the original module, the source module, and we're just going to program this into our salvage module. So to do that, we're going to press 2, which is program the device from buffer. How do I know that? I'll just show you. Okay, here's the main command list, and if you look here, command 2, program the device from buffer. Okay, well this command, you can either do it from the main command list here, or I can press command 5, we'll just do it in the buffer editor. Alright, so I'm going to press 2, I'm going to press yes, program from buffer start, and program the data from the buffer into the device. It's going to confirm it, and it's going to say programming complete, data verification is correct, and now we have transferred the double EEPROM data from our defective source module into our salvage vehicle module, and all we need to do is disconnect the clip and go install it in the car. You don't have to do any marrying, you don't have to do nothing else. You're done. You've just cloned this module. And like I said, the reason that it works is because the program in the flash is the same, and since the program in the flash is the same, the only information which would be different between these two modules is the information here and here. And what we did was we moved the data from our source module into our target module, and now all you got to do is install it in the car. All right. Well, that wraps up the demonstration explanation that I wanted to provide. Hope that answers your questions. If not, you can call us, email us, or you can post a comment. As always, if you have if you like this content, you can click the like button. And if you are interested in our products, and we would certainly appreciate your business if you are, you can contact us at our website, which is arlabs.com.